We're in 214, mathematically related values. And we'll read what it says. Some problems have more than one unknown variable, but the values are mathematically related to each other. When values are mathematically related, they can be mathematically expressed using just one variable in the relationship. So, for example, we have Tina here, and we have her sister Joan. Tina picked 3 more quarts of blueberries than her younger sister Joan. We really could have, if we wanted to, pick a J for Joan and a T for Tina. But then we'd have 2 variables in one equation, and that's really hard. So if we figure out if there's a relationship between Tina and Joan. So the 2 values are expressed here. The number of quarts Tina picked and the number of quarts that Joan picked. So if I have a J for Joan, and I have a T for Tina here. And so the phrase 3 more than shows mathematical relationship between the 2 values. If we pick a J for Joan, and Tina has 3 more than that, so we won't use a T, we can do J plus 3 to tell you what Tina's is.
Oh, okay.
And so this Joan has J amount, but Tina doesn't have T amount. She has whatever Joan has plus 3.
Oh, okay.
Does that make sense? Okay. So let's do Edward's. So Travis caught 4 times as many fish as Edward. And so
E
right.
plus 4.
Yeah, so if we have
No, 4 times E.
we have Travis and Edward. I'm just going to put Ed. And so it says Travis caught 4 times more than Ed.
So it'd be 4 times E.
4, which one's, so this would be 4, was this 4E? Yeah. This is 4E here?
Yes.
And this is E?
Mm-hmm.
So Travis caught 4 times more than Ed.
Mm-hmm.
Mm-hmm. And so you really could have, which would have been more complicated, if I wanted to use T for Travis, could I have written an equation for Ed's?
No.
I could have used T divided by 4.
Oh, but that's a lot of work.
It's like complicated because division's not as nice as multiplication. So depending on what they're going to ask you to do, it would be, in this case, it's easier to pick E for Ed and then 4E for Travis.
Mm-hmm.
Okay. Okay, so let's do the same thing. I want to come down. Yes. All right. A yardstick, which is 36 inches, is divided into 2 unequal parts.
So why?
Whoa. So I'm going to have to draw a picture of this. We have a yardstick, okay? All right. We cut it. How long is the whole yardstick?
12 inches.
But 36 inches. Okay, the whole thing is 36. Feel free to draw problems. If you don't know how to do a problem, draw some stuff to help you understand. All right. So and then they're wanting us to pick if this part is, let's say, X. How much is this?
Well, it depends on how much this is.
This whole thing is 36.
And how much is the X part?
Yeah, we don't know.
Oh, X. Subtract it?
Yes. So let's do. Yes.
Subtract X from 36?
Yes. So how long would this be?
36 minus X.
Yes. Very good. Very good. That's a very hard concept for lots of people. Very good.
It took me a minute.
Yeah. And so it wouldn't have mattered which side I made X, actually. Because if this side was X, if I had it like this and I would have picked this side for X, this still has to be 36 minus X. When you are doing your problem and get your answer at the end is when you're going to know if this one's the big one or that one's the small one based on your answer.
Okay.
Okay. All right. All right. We're going to talk about consecutive integers. What is an integer?
Whole numbers and their opposites.
Yes. So, not fractions, definitely.
Yeah.
So if I picked 3, a consecutive number with 3 would be 4, and 5, and 6, or 2, okay? So the ones, consecutive means the ones right after itself, okay? 3 and 5 are not consecutive numbers, because they're not right next to each other.
3 and 4.
Right.
4 and 5.
Right. So, if I had X as one of my numbers, what's the next consecutive number?
Y, I guess? Or does it even matter?
It has to be the same variable. So if I had
X?
3...
Oh, X to the X squared and then X cubed?
No. What do I do to 3 to get to the next number?
Oh, add 1.
Yes, so the next...
So 2x and then 3x and 4x and 5x?
So that would be like, if I did 2x, that'd be multiplying by 2.
Oh, that's true.
Instead of, you said to get to 4, I just add 1, right?
Mm-hmm.
So if we have x, how do I get to the next number?
Plus 1.
Plus 1.
Plus 1.
And then now, if I started with x, and I started with 3, how do I get to 5?
You add 2.
Add 2.
Oh, and so then you'd add 3.
You then add 3 and add 4.
And add
This is a list of consecutive numbers with algebra.
Okay.
Does that make sense?
Mm-hmm.
Okay, so we'd have x and x plus 1 and x plus 3.
Okay.
2, excuse me. All right. There is no rule that says which unknown is used for the starting variable, okay? So, right, just for a very much example of what we did back here, there's no rule that says that this one has to be x or that one has to be x.
Okay.
What is important is showing the mathematical relationship between the values is correct. So they're not worrying about which one you chose for x, but that one of them was x and one was 36 minus x.
Okay.
Because there really isn't a rule. I mean, if this one was called x, then this one would be also 36 minus x. All right. Then, wait. So, here we go. What is important is showing the mathematical relationship between the values correctly. In the last example, x would have been used to represent the third. If we would have said this was x, let's go that. If we would have said, with our 3, 4, and 5, if we said that this one was x, how do I go backwards?
Minus 1.
So this would be x minus 1, and this would be x minus 2, okay? And so we could have done consecutive values this direction also. Most people like to add instead of subtract, and so starting with the lowest one seems easier, okay? So then x minus 1 would represent the second, and this x minus 2 would have been the first. Both ways show the correct relationship between the consecutive integers, so your answers would still be correct. All right, when your mom's checking the answers, they might not have every single answer that's in there, though. So you'll have to make sure that when you're looking at it, that's why it's a good thing now that we have on your chart there. If you have questions, you can write them down.
Right.
This answer I think's right, but we're not showing that. Okay. I think we're done.
Wow.
Let's actually do number 1
Yeah,
now.
okay.
Angela is 5 times the age of her sister Julie.
So
Okay.
A times 5.
They want x to be
Oh.
Julie,
So
and I'm actually going to put the j up here.
wouldn't it be A times 5?
So this is x. And do I say Angelina? What did I say that? That's Angela. Angela is 5 times x. So they want you to find Angela now.
So it'd be J times X.
Where do we get the 5 from?
Oh, wait. J times 5.
Well, we don't have a j. They want us to use x.
Oh, X times 5.
Yes.
That's what I was
There
trying
we
to get
go.
at, but I'm
There you
saying
go. And I think they want you to write it like this.
Okay.
Just like this. So you'll have a 2 columns kind of like thing in
Okay.
your homework there. Okay. Okay, so let's do the next one. John is 1/3 the age of his father. So this time they're not telling you where you want the x. So we have John, and we have the father. Which one do you want to be, J, F, or X?
J, X.
Okay, so you want this to be J? Okay, so John is 1/3 the age of his father.
X times 1/3 because no. No, it wouldn't be times. If it was, so would it be J times? Subtract them?
How would you subtract them?
No, you wouldn't subtract them.
So let's just do some numbers in here. If you knew that John was 6, how did you figure out the father's? Or if we do the other way around, what if we knew the father was 30? How do we figure out John's? So which one do you want to put the number in John, under John's or under your
You
father's?
divide them, right?
Yes. Divided by what?
1/3.
Multiply by 1/3 or divide by 3.
Okay.
Okay. So if father is 30, what's John? Because John is 1/3 the father's.
So 1/3 of 30 is 15.
divide by 3.
Oh, okay, I'm sorry. 5 times 3.
So we're going to divide this by 3. What's 1/3? What's 30 divided by 3?
10.
There we go.
That would have been easier.
Okay, so then let's pretend that instead of 30, he's 90, which is really old. 90. So what would John be?
He'd be not 10.
Be
9.
He'd be divided by 3 again.
Oh, if you divided by 3, he'd be 30.
Yes. Okay, so each of these times, to get from here to here, we're going to go 30. So do you want to put the X under the father or under John?
John.
I'm going to put it under John. So how are we going to go that direction?
You're going to multiply.
By?
3.
Okay, so what would this be?
1/3. Or 3.
3 times?
1/3. X. 3 times X.
Yes,
Oh,
3 times
okay,
X.
okay.
Okay, so we can do it. And now, what if they wanted us to do it this way? What if, they didn't tell us, but what if they said they wanted this to be X? How would we go this way?
Divide.
Yes. So we can go X divide 3, or we could say 1/3 X. Okay?
Okay.
This is why they were saying this paragraph at the end says there's not a correct way to say which one's the variable. Are we making the variable for the father, or are we making the variable for John? Okay? And so, since the original equation said John is 1/3, it might have been easier if I go take all this out. It might have been easier since you have John is a certain amount. Whenever you see it like that, it might be easier to put that as the X. And the other guy is 1/3 of that.
Yeah. That,
Okay, but I like the fact that it was 3 times as much.
Yeah.
Looks prettier, but we had to do some numbers to figure it out.
Right.
And that skill we just did back here, wait, I took them all out, but putting those numbers in is really makes some real life situation. Well, okay, it's 1/3, I don't know what to do. Put some numbers in there and see if you can figure it out.
Okay.
All right, let's do another one. Michael used 3 more gallons of gas than Elliot. So we have Michael and we have Elliot, okay?
So 3
And so
plus E, right?
So which one you want? Elliot to be E, and Michael used 3 more than Elliot. So this is
So 3 plus
yes plus E. Yes. Okay. What if we would have made this M? What would Elliot be?
he'd be 3.
If he's 3 more than him,
Oh, if he's 3 more than him, he would have been. Wait, how would that have worked if he was M? If they're both variables?
so what? Look, now, because if we start over, if I took this one out, this is correct, by the way.
So it'd be M plus E.
Let's do some numbers. Okay, if he's 6, Elliot's 3 more, 9, right?
Mm-hmm.
Okay, and if he's 10, how do we go back here?
He's 3. Oh no, he's 7.
Yes. So if he's M, what's Elliot?
3? No. So kind of like saying. If,
To go this way,
so if he's. And then you subtract it
yes.
there.
So if he's M, he's
divided by though? I don't get it. What is he going to be?
so let's do some more numbers. Let's do if this was if he's 5, how much gas does
8.
Elliot?
No, because he's less than. He has less than him. So
Yes.
2.
2. So what did you do to go from 10 to 7 and 5 to 2?
I subtracted
How much?
2 or 3.
Good. Okay. So what if this was
Minus 3.
yes.
Okay.
So okay, there we go. So we can either make this E and he's E plus 3, or we can make this M and this M minus 3. Okay. Just like when we did back here, we were either multiplying going one way or dividing going the other. Okay. This is really good for your brain. Really good for your brain. All right. Both of those answers would have been correct. Okay. All right. Number 4. The cost of bicycle A is $17 less than bicycle B. So we'll go A and B.
So B minus 17.
So this is B minus 17, and this is B? Mm-hmm. Okay, so the cost of bicycle A is 17 less than B. Yes, very good.
Okay.
What if I would have put A here? What would that one have been?
Plus 17?
Yes, very, very good. Very, very good. All right. I think you got
never going to touch
You
on
got
that.
Very good. All right. I think they're going to have, let's keep going. Let's do a meter stick. 100 centimeters is divided into 2 unequal parts.
Okay, I did this last time. So, a meter stick. So, if you drew a meter stick and then you did a little section which was x.
You want this one to be x? Okay.
So, x divided by 100?
Wait,
100 divided by x?
We have 100 of it. This whole thing's 100, right? Okay. This part, let's say we even cut it apart and it's gone. How much is left?
We don't know.
You took x away. What if we took 5 away? What would be left?
95.
Because what did you...
We're subtracting,
Very
not
good.
dividing.
Very good. Very
so
good.
it'd be x minus 100.
Yes. See how numbers really make it easier if you say, well, what if I play that what if game? So this would be how much here? If that,
x minus 100.
be careful.
100 minus x.
Yeah. How do you know
That's
which?
what I meant to
How do you know
say.
which is it?
Because you can't. It would be negative if you did 100 or x minus 100.
Right. Because we know that this has to be, no matter where we cut this pieces have to be less than 100. Very
Right.
good. All right. Craig had twice as many pennies as nickels. So we have pennies and nickels.
Twice as many pennies. So p times p squared. No, 2p.
Do you want to put some numbers in here?
Yeah.
What if he had 6 pennies? So Craig had twice
He
as
had
many.
12 nickels.
He has twice as many pennies as nickels.
So he'd have 3.
Yeah, and so if he had nickels and he had 5 nickels, how many pennies would he have?
Ooh, n divided by 2.
N divided by 2. Is this n? So if to come up to here, would this be?
25.
This would be 25? Because we went 6 and we doubled, didn't we? Because it says twice as much.
Oh, so it'd be 10.
So this would be 10.
10, yeah. Where was I getting 25?
So if this is 5 and we come over to go this direction, we doubled it, didn't we? What if we, and when a minute ago, we actually didn't go this direction. We went this direction and we divided, right, to go this direction. So if we started with n and then we divide by 2 to get over here, is that what we did? We had 5 and did we divide to go backwards?
No, we multiply.
We multiply.
So it'd be n times 2.
Yes.
Okay.
You understand?
Yes.
Okay.
I see what I was doing wrong. Cause that wouldn't have made any sense if you. Yeah.
We can also go like that. Okay. So let's go 4 consecutive integers.
That's what we did here.
Right.
So like x plus 1, x plus 2, or x, and then
Okay.
x plus 1, x plus 2, x plus 3.
Now, how can we end it with a 3 when we have 4 of them?
Because x is like representing
Yeah.
0.
Very good. All right. Or the first one.
Yes.
Okay. All right. Those are difficult tonight. They're going to have some more review in here anyway, but that's okay. And you're going to keep doing those over and over, but it's good that we did those together. And I suggest that you do these by yourself now,
Okay.
and then go back and look at this to see the answer. Okay. All right. We're done.